Not so long ago, there was a revolution in astronomy. We learned that planets are almost an inseparable part of stars. Almost every star we've studied in enough detail turned out to have its own planetary system. But when the initial excitement settled down a bit, something much stranger was discovered. The solar system doesn't fit well into this new generalized picture. Moreover, we still haven't found a single system that truly resembles ours. This is troubling. Either we are on the verge of discovering thousands of solar-like systems hidden in future Gaia satellite data, or the solar system is a rare cosmic oddity, the result of an extremely unlikely set of circumstances. And both options are possible, and both have profound implications, especially for the question of how rare life is in the universe. And what do you think? Are we the exception? Exoplanets are searched for many reasons, but the main one is the attempt to understand whether there are other worlds similar to Earth. So far, we know only one inhabited example, our planet. That's why every time we find an Earth-mass planet at such a distance from a star where liquid water might exist, it attracts special interest. Water, by all standards known to us, is critically important for life. However, despite dozens and dozens of such discoveries, we still don't know exactly what factors trigger its emergence. Is mass and distance enough, or does the type of star also play a crucial role? It gets even more intriguing when an Earth-like planet orbits a star similar to the Sun. We know of several such cases and suspect that there are many more, but perhaps that's still not enough. There are others as well. For example, it has long been suggested that Jupiter played a key role in Earth's history by protecting the inner solar system from destructive streams of comets and asteroids. How many sun-like stars do we know that have both an Earth-like planet and a distant gas giant like Jupiter at the same time? None. Could this mean that such systems are extremely rare? Or is it just that we haven't been able to detect them, but the situation is starting to change? Planets are incredibly hard to see directly. They are small and dim compared to their stars. Yes, there are direct images, and here they are, but they are not suitable for large-scale surveys, so astronomers mostly rely on indirect methods. The first exoplanets were discovered in 1992, around a millisecond pulsar, a neutron star spinning 160 times per second. Small irregularities in the rhythm of its pulses revealed the gravitational influence of planets. Impressive, but it had almost nothing to do with the solar system. Then came the Doppler method, which measures the star's wobble around the common center of mass with its planets. It was this method that, in the 1990s and early 2000s, discovered hundreds of hot Jupiters, massive planets on short orbits. Earth, however, remained out of reach. The breakthrough came with the launch of the Kepler telescope in 2009. It continuously observed 150,000 stars and recorded tiny drops in brightness as planets passed across the disks of stars. By the mid-2010s, Kepler was discovering hundreds of exoplanets each year, including the first Earth-like worlds. Based on this data, astronomers estimate that there may be about 11 billion Earth-like planets in the Milky Way. The number is impressive, but there's a catch. Most of the discovered systems are nothing like ours. Instead of a clear division between rocky inner planets and gas giants on the outside, we often see dense chains of planets that are about the same size. The so-called peas in a pod are just the most famous example. So why is the solar system arranged differently? One of the leading ideas is the Grand Tack hypothesis. Jupiter migrated toward the Sun in the early history, destroying forming planets and then moved back. If such a scenario is rare, then our configuration might be rare as well. But there is also a more mundane explanation. Maybe we just can't see distant Jupiters very well. This is where he enjoys the scene. He comes out. Astrometry is a method that measures tiny shifts in a star's position in the sky. Distant massive planets make stars trace slow but noticeable arcs. You just need to measure the position with fantastic precision. This became possible with the launch of the Gaia satellite in 2013. In more than 10 years, it has measured the positions of about 1.3 billion stars with a precision comparable to observing a coin on the surface of the moon. In the third data release of Gaia, the first astronomical exoplanets were confirmed, massive super-Jupiters on distant orbits. And this is just the beginning. It is expected that the Gaia data release, for release in 2026, will lead to the discovery of about 7,500 exoplanets. And the final data release, 5 release in the early 2030s, will reveal tens of thousands. Gaia is sensitive specifically to those planets that previously escaped detection, gas giants at great distances. Gaia will not directly observe exo-Earths. Their influence is too small, but transit missions like Transiting Exoplanet Survey Satellite will study the inner regions of these same systems. Together, these methods will provide an almost complete portrait of planetary architectures, and perhaps among them at last, a new true copy of the solar system will be found. And if not, what will that mean for our understanding of life in the universe? Well, Earthlings, this is not the end of the video. We still have some very interesting and simply spectacular episodes ahead. But for me to keep delighting you with all the characters of the cosmic expanses, I need your feedback. You can express it quite simply. All you need to do is give an electronic like under this video, since we simply don't have any other kinds of likes, and continue the phrase, "I know." This way, you'll let us know that we're moving in the right direction. Don't switch channels.